In this lecture, we want to continue talking about organizing and summarizing data by moving into talking about organizing quantitative data. Now, in a previous lecture, we saw or talked about how you organized qualitative data, which are categories. So now quantitative data is numerical measures. So now there's two types of quantitative data, right? There's discrete, which are counts, and there's continuous, which are measurements. So we'll talk about ways to handle both those. Okay, so I'm going to introduce this first topic with an example about television. Okay, so suppose you have 50 randomly selected households, and what you did was you asked them, how many TV sets do you have in your household? And these are the results. So, a lot of households said I have one, some households said I don't have any, some are 3, 5, some households, look at this, six TV sets in their house. Okay, so now what you want to do is you want to record, or you want to summarize this data, okay, this 50 data values, with a frequency distribution or frequency table. Okay, so just like you did with qualitative data. All right, but this is quantitative data, right? This is discrete data values. So how do we take these 50 raw data values and summarize them? Well, it turns out that how you group your data here is the most important part. So what I want to do is I want to take this data and I want to develop little groups of classes that I put my data in. Okay, so there's going to be two methods for grouping your data. We can use what's called the single value grouping. This you use with discrete data in which there are a small number of distinct values. We'll look back here. This is discrete data, and it looks like there are a small number of values: 0, 1, 2, 3, 4, 5, and 6. Right? So there's only a couple values there. So this first one here might be this single value grouping. Then I'll talk about limit grouping, and this is you use when the data are expressed as whole numbers and there are just too many distinct values to employ single value grouping. So we'll handle that one next. Okay, so this is how you do the single value grouping with the television. What you do is you list first all the different, I'm going to say quote unquote classes, all right, the different values. So there were households with 0 TVs, 1, 2, 3, 4, 5, and 6. And then basically what you do, just like with qualitative data, is you count, well, how many households had 0 televisions? Well, it was 1. How many households had 1 television? Well, there were 16, and so on. And this is what your data would look like. So from here, you can easily just take this and figure out what the relative frequency is for each of these classes here. So you take 1 divided by 50, you get 0.02. 16 divided by 50, you get 0.32, and so on. So this is that single value grouping. All right, let's take a look at a different one. Okay, so this example is about investments. So this is days to maturity for 40 short-term investments. Okay, so what I have here is a list of days. Now this is the time it takes for short-term investments to mature. So even though these are listed as whole numbers, right, the time it takes is a continuous variable. So how we're going to handle this is a little bit different than just listing all the possible values and count how many times they occur. All right, so what you're going to do is you're going to use this process called limit grouping. So these are going to be the terms we're going to use for limit grouping. We're going to have what's called the lower class limit. This is the smallest value that could go into a class. You're going to have an upper class limit. This is the largest value that goes into a class. Okay, and then you're going to have what's called the class width, which is the difference between the lower limit and the upper limit. Okay, and what basically is going to happen is any values that fall between the lower and upper limit, you're going to count. Okay, you're going to put those in a group together. We identify this thing called the class mark, which is the average of the two class limits of a class. And basically what this does is this is just kind of like a identifier here, and we're not going to use the class mark too much when I construct these, but this is just an identifier. All right, so going back here, let's look at these investments, these days to maturity. So it looks like 70, 64, 99, 62. There's some down in the 30s. Does it look, are there any in the 40s? Yeah, there's some in the 40s, the 50s, the 60s. So listen to how I'm saying this. So a lot of these examples, it's kind of obvious how you want to group them. So it looks like we want to group all the 30s together, all of the 40s. Well, if we're going to group the 30s, okay? The lower limit would be 30, and the upper value would be 39. If we wanted to group the 40s, the lower value would be 40, and the upper value would be 49. So the class width, the difference between the lower limit of a class and the lower limit of the next higher class, so it's 30, and then the next lower limit was 40. 40 minus 30, that class width is 10. So what you're going to do here, you're going to have days to maturity. You're going to have your groupings here be a range of values. So we're going to group all the 30s together, all the 40s, all the 50s, all the 60s, 70s, 80s, and 90s together. And then what you're going to do is you're just going to count how many values are in each. So like how many values were in the 30s? There were 3. How many values were in the 40s? 1, and so on. And here you can see your frequency counts. And then from this, you can obviously find the relative frequencies very easily. Okay, so just to recap here, when you have data that's discrete, single value grouping, no problem. Data that's continuous like this, you're going to need to use this limit grouping, and your classes are going to be ranges of values. All right, how you show this now, okay, a visual representation of this is what's called a histogram. So a histogram displays the classes of quantitative data on a horizontal axis and the frequencies or relative frequencies or percents of those classes on the vertical axis. All right? So the frequency of each, or relative frequency, depending how you set it up, of each class is represented by a vertical bar whose height is equal to the frequency or relative frequency of that specific class. And this is important. This is where it's different from a bar chart. The bars should be positioned so that they touch each other. Okay, so that's important. They touch each other or build off each other. Okay, so for a single value grouping, we use distinct values of the observations to label the bars. Okay, with each such value centered at its bar. For limit grouping here, we use the lower class limits, or equivalently the lower class cutoffs, to label the bars. So note, some statisticians and technologies use those class marks I talked about, or class midpoints centered at those bars. But what we're going to see when you do I is going to use the class limits, or the limit grouping, or the lower class limits, excuse me. Okay, so here's how we construct this histogram. First, we obtain a frequency or relative frequency distribution of the data. All right. Then we're going to draw a horizontal axis on which to place the bars and a vertical axis on which to display the frequencies. Then for each class that we have, we construct a vertical bar whose height equals the frequency of that class. And then finally, you're going to label the bars with the classes as explained in our definitions here, okay? And the horizontal axis with the name of the variable and the vertical axis with that frequency. Okay, let me show you the histogram for the TV. All right, and this is the single value grouping method. All right, so you're going to start with a horizontal axis and a vertical axis here. And along the horizontal axis, you're going to put the number of classes that you had, or what the classes were. Well, you had 0 classes, 1, 2, 3, 4, 5, and 6. And then along the vertical axis, you're going to put the frequencies. Okay, so I'm going to count by 2s here. 2, 4, 6, 8, 10, 12, 14, 16. And if you look here, all right, going back at the data, all right, the number of households that had 0 TVs, there was 1. And if you look here, that's where this bar chart, this bar on the histogram goes up to, 1. There were 16 households that had 1 TV, so we draw this bar up to the top to 16. And you do the same for the rest of the classes. Now you could do relative frequency instead. Okay, so instead of frequency, you have those relative frequency values here. And notice that the two histograms look exactly the same. And that's what will happen. It doesn't matter if it's frequency or relative frequency, the histograms will look exactly the same. All right, let's talk about that limit grouping, that days to maturity. Okay, so again, we're going to do the limit class along the bottom. So the lower limit of each class was 10, 20. It actually started at 30 to 40 to 50 to 60, and so on. So this bar here represents all the values in the 30s. Okay, it looks like there were 3 of them. And then there was 1 here. And then going back, you can see how the next group, the 50s, there were 8 of them. Up to here, and so on. And it's the same thing if you did, instead of doing the frequency, you go back and do the relative frequency of this. And the two look exactly the same. Okay, so along The horizontal axis, you put the classes. Vertical axis, you get the frequency or relative frequency. It doesn't matter. Okay, what I want to do now is talk about two other different types of ways to visually show this data. And the first one is called a dot plot. Okay, so a dot plot is a graph in which each observation is plotted as a dot, obviously, at an appropriate place above a horizontal axis. So observations having equal values, you just stack them right on top of each other. All right, so let me talk about how to do this and then show you. So the first thing you're going to do is you're going to draw a horizontal axis that displays the values of the quantitative data. Okay. Then the next thing you're going to do is you're going to record each observation by placing a dot over the appropriate value on the horizontal axis. And then the last thing you're going to do is you're just going to label the horizontal axis with the name of the variable. Okay, so here's an example. And this is about DVD players. And one thing I was thinking about as I was writing this example is, does anyone even buy DVD players anymore? When I was in college, everybody was buying DVD players. But anyways, I digress. So here are prices in dollars of 16 DVD players. These are incredibly expensive DVD players for some reason, okay? So it looks like one costs $210, there's another one that costs $210, and so on. So what you would do is you draw a horizontal axis and you label down on the bottom price, okay? So it looked like the lowest possible price here was $197. So I'm going to start at $190. And the highest it looked like was $224, so I'll go up to $230. And like when I get to the first value, $210, I'm going to go above $210 and I'm just going to put a dot. I go to $224. You go over to $224, I put a dot. $208, right here, I put a dot. $212, I put a dot. $219, I put a dot. Another $219, I put another dot above it. $209, I put a dot. $212, there was already a value there, so I'm going to put a dot above it. And you just fill it out this way. And this is just another way to represent or to visually display the data. The last thing I want to talk about is what's called the stem and leaf diagram. So in a stem and leaf diagram, or sometimes called a stem plot, each observation is separated into two parts, namely a stem, all right, this is consisting of all but the rightmost digit, and a leaf, which is exactly the rightmost digit. All right, so here's how you construct a stem and leaf diagram or a stem plot. Okay, so step one, think of each observation as a stem consisting of all but the rightmost digit. All right, and the leaf is that rightmost digit. All right, so we're going to use a different example, but like here in this right here, the stem would be the 21 and the leaf would be the value 0. The stem would be the 22 and the leaf would be the value 4. All right, you're going to write the stems from smallest to largest in a vertical column, all right, to the left of some type of vertical rule. And then you're going to write each leaf to the right of that vertical rule in a row that contains the appropriate stem. And then finally what you're going to do is you're just going to arrange the leaves in ascending order. All right, they're a little confusing. Let me try to explain this. All right, so let's go back and look at the days to maturity for 40 short-term investments. All right. For each one of these, okay, the stem is the first digit and the leaf is the second digit. Okay, so it looks like the lowest possible value here ended up being a 36, where is it? Right here. And the highest possible value ended up being a 99. So what you're going to do is you're going to write all the stems first. So that's the first digit, which would be 3, 4, 5, 6, 7, 8, and 9. So then what you would do is you do the following. I'd start at 70, okay? I had a 7 here. All right, that's the stem. Its leaf was a 0. I go down to the value 62. All right, the stem is 6 and its leaf is 2, so I would put a 2 here. I go to 75. The stem is 7. It's already there. Okay, so I just put another leaf, 5. 57, I go to the stem 5 and I write the 7. 51, the stem is already there, 5, and I write another leaf of 1. And you would fill out the rest of the data the following. Like, let me just do couple more here. 64, the stem is 6, the leaf I would put is a 4, and I put it right after the 2 that I already had. 38, 3 is the stem, the leaf is 8, I'd put the leaf 8 right here. And then after you filled it out, just going down each column, all right, you have this data that's just all over the place, and all you do is then you arrange the leaves in ascending order, and that's it. All right, let's just do another one here. So I have cholesterol levels for 20 high-level patients. So I want to show stem and leaf diagram of cholesterol levels. Now this is interesting, using 1 line per stem, and then there's another thing called using 2 lines per stem. And I'll try to explain that. So the 1 line per stem. So remember, everything but the rightmost digit is the stem. So it looks like 21, 21, 20, 21, 21, 22, and 19. So it looks like I got to go from 19 to 22. So 19, 20, 21, 22. When I do that, and I just go through, all right, 210, I go to 21, I put the leaf of 0. Then 21, I put the leaf of 7. This one is already filled out in ascending order. Now, this is 1 line per stem. Notice how there's a ton of data grouped up here in the middle. So the way the 2 lines per stem is I write the 19 twice, the 20 twice, the 21, the 22, and so on. Digits 0, 1, 2, 3, and 4 go in the first stem. Leaf digits 5, 6, 7, 8, and 9 go in the second stem. So like for the values 20, like when you got to 208, you would go to the second stem because it's the leaf is 5, 6, 7, 8, or 9, and you would put that leaf there. And that's just another way to represent it now here with 2 lines per stem.